Welcome to this YSL video. In this tutorial, we're going to show you how you can use dynamic SQL in Microsoft SQL Server. We'll start the video with a quick explanation of what dynamic SQL actually is, and then we'll show you two techniques you can use for executing dynamic SQL statements. We'll spend a bit of time teaching you how you can build a dynamic SQL string using concatenation, and that's going to include a little hint about how you deal with problems arising from concatenating numbers as well. Once we've covered the basic techniques, we'll move on and show you a few practical uses for dynamic SQL. Mostly that's going to involve creating stored procedures. So we'll teach you about using parameters in a stored procedure, so your user can pass in bits of a dynamic SQL statement. We'll show you how you can use the in operator to create some quite neat dynamic queries. And finally, we'll show you one of the main dangers of using dynamic SQL, and that's called SQL injection. So let's get started. Using dynamic SQL means that you can take any valid SQL statement, convert it into a string of text, and then execute that string of text as though it was the original SQL statement, which admittedly sounds fairly pointless when you put it like that, but there are good reasons for wanting to use dynamic SQL, and we're going to mention a few of those throughout this video. First of all, I'd like to show you the two different techniques you can use to execute a dynamic SQL statement. The simplest way to use dynamic SQL is to use the execute command. So in order to make that work, I first of all need to convert my SQL statement into a string, and I can do that by simply adding a single quote to the front and to the end of it to turn it into a string of text. Then at the start of that string of text, I need to write the word either exec for short, or execute if you prefer the full keyword. And then I need to enclose my string in a set of parentheses or round brackets. And that's it, I'm ready to go. So when I execute this code now, what I'm going to get are the same results as though I had just executed the select statement by itself. Apparently not a very useful example, but as I say, we will show you uses for this further through the video. The second way to use dynamic SQL involves using a system stored procedure. We have to start again by converting our select statement into a string of text, so we can do that by adding the single quotes to either side of it. And we also have to make sure that the string of text is a Unicode string, so its data type has to be n-varchar for this stored procedure to work. The easiest way to achieve that is to just add the letter n to the start of the character string, and that creates a Unicode string. Then we can go about calling our stored procedure, so we can do that by writing the word exec or execute again, and then the name of the stored procedure, which is called SP_execute SQL. So it's a built-in system stored procedure which accepts a Unicode string which can be interpreted as a valid SQL statement. So all I need to do again is to execute this code, and I'll get exactly the same results as I saw earlier. As there are a couple of different ways of using dynamic SQL, it's worthwhile quickly mentioning what the key differences between the techniques are. So of course, apart from the obvious ones, such as the first technique being shorter to type, as you haven't got to call the stored procedure's name, and it also being a little bit less fussy about data types as well, so you don't have to ensure that it's a Unicode string when you use the execute keyword. The key difference comes from the query plan that is generated when you use the stored procedure. So whatever SQL statement you pass to the stored procedure, SQL will generate a query plan for that select statement and store it in a cache. And that means that subsequent times that you run this same select statement, or even moderately different ones where you perhaps tweak the select list, those will run more quickly than the first time you do so. And that's something that using the execute keyword by itself doesn't do. Every time you execute this select statement using the execute keyword, it's as though it was run for the very first time. So using the stored procedure can make your queries, your dynamic SQL, more efficient. There is one other advantage to using the stored procedure as well, and that's going to become clear when we start talking about using parameters. So there are extra arguments for the stored procedure which allow you to add parameters to a select statement, which is going to be very, very useful to us later on. The real power in dynamic SQL comes from when you start concatenating your statements from various individual bits of text. So what we're going to do in this example is create a simple statement which allows us to replace the name of the table that we're selecting our records from. So this small part of our statement is going to become the dynamic part of our dynamic SQL. Now this technique works best if you're using variables, so the starting point here is to declare a couple of simple variables. One that can hold the name of the table I'd like to use, so I'm going to declare @TableName, and the data type of that is going to be nvarchar. And I know my table names have a maximum length of 128 characters, so I'm going to fix the maximum limit of that data type to 128. And it also makes sense, I think, as well, to declare another variable which holds your main SQL string. So I'm going to declare a variable called @SQLString, and that's going to be nvarchar. I'm going to use max. The next step is to set the value of my table name variable, and I can do that with a simple set statement. So let's say set @TableName, and I'm going to make it equal to, let's see, TBL film. We'll use the same table name that we're already using in our select statement. Now that I've got that value stored in my table name variable, I want to join that together with the main SQL string to generate a complete statement. So let's modify this line that we have here. I'm going to set @SQLString and make that equal to the starting part of my select statement is always going to be the same. I'm always going to be selecting star from, but it's this part that's going to become dynamic. So I'm going to move the TBL film table name, remove that from the statement, and instead I'm going to concatenate, by using a plus symbol, whatever table name is stored in my table name variable. All that we need to do now is execute the resulting SQL string, and to do that I'm going to use the system stored procedure. So I'm going to choose to exec sp_execute SQL, and I'm simply going to call on my SQL string stored in my SQL string variable. So there we go. If I execute this query now, what I should see is, again, an entire list of films, because that's the name of the table that I passed into the statement. But I can happily now easily modify the name of the table that I'm using. So if I choose actor, that will automatically modify the SQL string that's executed and return a list of actors instead. And I can continue doing this to change the name of the table to anything that I like. One thing you have to be careful of when you're concatenating strings in SQL is when you try to add a number to the string. So in this example I'm trying to create a system whereby I can choose the number of records I display from a specific table in a specific order. So I have a variable here called @number, which can hold an integer, and the idea should be that I can set @number equal to whatever number I want. So I'm going to go for 10 again. What I'd then like to do is build an SQL string which incorporates that value, so the value stored in the variable. So I'll separate out the parts of my SQL string here that I know will be fixed. So that's the select top, and then the number will be fed in there, and then the star from TBL film, etc. And then I can simply replace the absolute value 10 with a reference to my variable called @number. So I can concatenate in the number variable. Finally, I want to store the entire result of this concatenation in my SQL string variable. So I can say set @SQLString equals that statement. The problem is when I try to execute this query now, I'm going to see an error message appear as a conversion error. And it tells me that it's tried to convert the nvarchar value select top into the data type int. So what SQL has actually tried to do is convert the phrase select top into an integer so that it can arithmetically add the words select top to the number 10, which is clearly complete nonsense. What we need to do is the opposite. We need to convert the number into a string. And there are two techniques for doing that. You can either use the cast function or the convert function. So I'm going to create another variable which will hold the converted version of my number. So I'm going to declare @numberString, which will be a varchar or nvarchar, and I'm going to give it a maximum limit of 4 characters. And then after I've set the number variable, what I can do is set the value of my numberString variable by converting the first one. So I can use either cast or convert. I'm going to use cast because it's shorter to type more than anything. I'm going to cast @number as nvarchar4. And there we go. All I need to do now is replace my reference to the original number variable in my SQL string with a reference to numberString instead. So if I execute this statement now, what I should find is it finally works. And if I change the number of records that I want to retrieve, that should also affect the results as well. So there we go, there's using numbers in an SQL string, making sure you can handle the conversion error that you're likely to receive. Now it's fairly unlikely that you'd see or use simple scripts like the ones we've created so far to use your dynamic SQL statements. More commonly, you create a stored procedure into which you can pass a parameter which would affect the select statement itself. So what we're going to do here is create our own stored procedure which allows us to pass in the name of a table. So we're going to create proc sp variable table. I can spell table, that would be better. And this stored procedure is going to have a single parameter. So instead of round brackets after the stored procedure's name, we're going to have a single parameter called @table name, as we saw earlier on. And that data type is going to be nvarchar 128 again. I'm then going to say this stored procedure, the definition of this stored procedure as, and I'm going to store the logic within a begin and an end block. We've created videos on how you create stored procedures previously, so that goes into this in a lot more detail. You might want to look those ones up. But this basic stored procedure is called sp variable table. I pass in a table name, which must be a string, and the end result, what I want to happen, is that my procedure shows me the results of the dynamic SQL statement that will be built. So let's continue and declare a variable which can hold our SQL string. So declare @SQL string, which will be nvarchar max. And then I can simply build my SQL string by saying set @SQL string equals n and select star from plus whatever value has been passed in through my table name parameter. So it's exactly the same technique as we were doing previously, but using a stored procedure makes the code much more reusable. The final step then is to execute my system stored procedure, sp_execute SQL, and pass in my full @SQL string, and there we go. So if I execute this code now, that will generate my stored procedure called sp variable table, and I get a lovely message saying that it's completed successfully. To use that stored procedure now, I can copy its name into a new query window. So I can do that with Control and N on the keyboard. And if I say exec followed by my stored procedure's name, I can then ask it for, say, TBL film the first time. And if I execute this, it will show me the list of films. If I modify the name of the table and execute it again, it gives me a different list of records. So that's the beauty of using dynamic SQL with a stored procedure. It encapsulates the logic, as all stored procedures do I suppose, encapsulates the logic of a complex procedure and allows you to call it and reuse it in a much more simple fashion. If you're going to use stored procedures to generate your dynamic SQL, it's worthwhile knowing a couple of extra things about stored procedures in general. So the fact that you can modify or alter a stored procedure after you've created it. So for this example, if I decide that I'd like to include an extra parameter, for instance, I can say alter proc sp variable table, and I'm going to add in another variable, or sorry, another parameter called @number. You hopefully see where I'm going with this, and that's going to be int. So when I call my stored procedure now, I can pass in the number of records I'd like to return. What I've then got to do is convert that number into some kind of text data, so probably nvarchar. So I'm going to do that in the same way I did earlier on. I'm going to declare @numberString, which will be nvarchar. I'm going to give it a max of 4. And then I can set @numberString equal to cast @number as nvarchar4. Now I have to build in that value into my main SQL statement. So in my line which sets my SQL string, I don't just want to select everything, I want to select the top so many records from my table. So I'm going to add the top keyword, and then I'm going to isolate the individual bits of my SQL string. So I'm going to select top And then it's at this point that I like to build in or draw on my number string variable. So I want to concatenate plus add number string plus, I've forgotten the string part, there we go, number string, plus everything from plus table name. So when all of this is joined together, it generates a valid SQL string. Trust me on that one. So all I need to do now is execute this code to make the alterations to my stored procedure. So if I execute that and return to my test code from earlier on, I've now got the ability to add on a second parameter. So I'm going to pass in the number 10, and I should now return just 10 records from the table I've asked for. If I change the table name and change the number I've asked for, it will give me a different number from a different table. So there we go, another neat demonstration of how to use stored procedures to encapsulate your dynamic SQL statements. Dynamic SQL is also quite handy for making the content of an in operator dynamic and flexible. So in this example, I'm trying to display films that were released in a certain list of years. So my in operator allows me to specify a comma-separated list of values that I'm looking for. If I execute the query, I'll see a list of all the films released in 1980, 1990, 2000, etc. So that's affected by whatever list of entries I enter here. So to make this into a dynamic SQL query, I'm going to create another stored procedure. So I'm going to say create proc, and call this sp film years. And I'm going to simply pass in, or allow my user to pass in via a single parameter at year list. And that's going to be nvarchar max. So rather than passing in a list of numbers, my user is going to pass in a string of text that contains that comma-separated list of numbers. So now I need to add in the various other parts of my store procedure, so the as keyword, and I'm going to have a begin and an end block. So right at the bottom I'll have end, and then just to make it a little bit clearer to read, I'm going to indent the select statement itself, one space, so you can see what's part of my SQL statement, my store procedure. Standard things that I'm going to do then, just as we've done previously, I'm going to declare a variable called @SQLString, and that's going to be nvarchar max, and that's going to allow me to hold the full SQL string. Then I'm going to set the value of that variable by building it up out of the component parts of this select statement. So everything from the word select up to the open round brackets there, the open parenthesis, is part of the SQL string and will always be the same. This part will be different, the list that I'm going to pass in, but also the following parts, the close round brackets and order by film release date, will also always be the same. So all I need to do now is replace this comma-separated list of values here by concatenating my @yearList parameter. There's a neat feature of SQL when you're writing it is you can actually split a string of text across multiple lines. I know it would make a little bit more sense, a little bit easier to read, I think, as a one single line, but it's a neat trick to lay things out a bit more neatly. Hopefully what I can do now then is, oops, I forgot about the ends to make sure these are Unicode strings. What I should be able to do now, that I've remembered to do that, is to call on my store procedure. Our system store procedure called exec sp underscore execute SQL. And if I pass in my standard @SQL string parameter variable, I should now be able to run and create my store procedure. So all that remains is to give it a quick test to see if it works. If I copy the name of my store procedure and then create a new query window by pressing Ctrl and N, I should be able to say exec, paste in the name of my stored procedure, and then as a string I should be able to simply say things like, let's go for 2000, 2001, 2002, for example. When I execute this, my list of results should reflect the years that I've passed in to my stored procedure. While we're talking about stored procedures and parameters, I thought it was quickly worthwhile mentioning that the SPExe SQL store procedure actually has its own list of parameters as well. So far we've only been providing a value for the first parameter, and that's the SQL string that we want to execute. But it's possible to actually parameterize that SQL string itself. So what I mean by that is you can do things like this. You could add a where clause to the select statement you're trying to execute, and simply write in things like, I'm going to ask for where film runtime minutes is greater than the value of a parameter. So I'm going to call my parameter at length. Now, of course, that parameter itself doesn't actually exist. So the second parameter of our store procedure allows us to define any extra parameters, and you do that again as a string of text. So it's an n varchar string where at length int. So that's the definition of any parameters that I've referred to in my select statement. The final parameter of SPExe SQL is to set the value of any parameters you've defined, and you do that not as a string, you do it as a literal sort of definition, assignment of a parameter. So at length equals, let's say, 120. So it's a bit of a strange way of doing things. You refer to a parameter that doesn't yet exist in your select statement, you then define that parameter, and subsequently set its value in the final argument or the final parameter. If I execute my script, what I should see is a list of results where the runtime in minutes is greater than 120. If I modify that number, let's say 180, that should return a much shorter list of results, and there we go. You can extend this and generate even more parameters for your select statement. So if I add in an extra criterion into my where clause, I can say and film release date is greater than a variable or parameter called at start date, for instance. If I want to define that parameter now, I go to the second parameter of SPexe SQL and add another definition to my list. So in the same string, separated with commas, I can define at start date as date time. The way that you then assign a value to that parameter that you've created is via an extra argument or an extra parameter of SPexe SQL. So you don't set the value of start date in the same parameter as you do at length. You actually add another parameter and say at start date, which you just have to pretend exists, at start date equals, and then pass in the date or value you want to assign to that parameter. So I'm going to look for any films whose runtime is longer than 180 and was released after the first day of 2000. If I execute all of that, that's exactly the set of results I'll see. Now, you can't really talk about dynamic SQL without mentioning one of its biggest potential dangers, and that's something referred to as SQL injection. So I'm going to go back to a previous store procedure that we created, one that allows me to pass in the name of a table and for it to return a set of results from that table. So just to remind you what the store procedure looks like, it's a single parameter, table name, we pass that in when we call the procedure, that's built into the SQL string to select everything from that table, and then the string is executed. So when I call this as intended, it allows me to see a list of films if I ask for the table of films. It allows me to see a list of actors if I ask for the table actors, and any other table that I ask for. Now imagine that this stored procedure isn't sitting in a simple script like this. It's actually sitting behind the search function of a website, for instance. So, for instance, like the one on the WiseR website, there's a little search box there, and it might well be that whatever value you type into that search box, when you click go, that could be executing a stored procedure which returns results from the server. Now imagine somebody was using that search box who knew a little bit about how SQL works. Somebody might decide to do something horrible like this. They could add a semicolon to the end of the parameter they've passed in. The semicolon is the statement terminator in SQL. You don't need it in Microsoft Transact SQL, but it doesn't harm it if you do add a semicolon, so each statement is ended by a semicolon. So if they've ended one statement, they could then choose to begin another, and they might choose to do something horrible like drop table, for instance. And if they knew, or predicted, or even just guessed the name of a table in your database, for instance, I know that I've got a table in my database, as I've just created it, called TBL test, and there it is. So if I said to drop table TBL test, when I execute this script now, I'm actually passing a string which consists of two complete SQL statements to the SPExe SQL store procedure. So when I execute it, although I'll see my list of results as I'd expect, what's also happened, if I refresh my table of, my folder of tables, you'll see that TBL test will disappear. And that's a horribly frightening idea. Imagine a website which contains those sorts of search boxes with dynamic SQL in the background into which you can pass any sort of SQL string you like. Our WiseOwl weblogs, it's surprising how frequent people attempt to perform SQL injection attacks. On a daily basis, we can see people searching for silly things like SQL semicolon and then something horrible and nasty that they try to do afterwards. Fortunately, the WiseOwl website's got some controls in place that prevent that from happening, otherwise we wouldn't be running a very successful business. But there you go, that's one of the dangers you have to be aware of. Now there are many different ways of controlling for SQL injection attacks, and rather than go into them in this video, what I'm going to do is I'm going to point you to the ultimate resource for dynamic SQL. It's a website called Sommarskog, which I will post a link to this as well in the description of the video. But this is by far and away, I think, the best resource on the web for dynamic SQL. And there is a nice little section here on dealing with SQL injection attacks and what that actually is and how you get around it. So I'll leave that up to you to read about, because there are several different techniques for solving the problem. And that kind of brings us to the end of this video. So all I'm going to do is leave you with a little famous cartoon by XKCD, which is all about a very geeky joke to do with dynamic SQL. But hopefully, having watched this video, you're in a position to understand it. If you've enjoyed this training video, you can find many more online training resources at www.wiseowl.co.uk.